Good morning, astronomy students. This is a follow-up on that actually class that we had early in the week. This is something that I promised we will do. Let me share the screen first. That I promised that we will do following up the discussion on problem 14, which was really not in depth enough, number one. Number two, also, I may have given you the wrong impression that the comparison has to be between the day on Venus and the day on Earth, and that's not really the case. We're going to focus entirely on Venus, actually, and look at it from the vantage point of its rotation versus basically its revolution. And we will make that comparison and see exactly what's going on with the day on Venus and how it's going to be aligning itself with the Earth in an inferior conjunction. So first of all, the day on Venus. So this is one day on Venus. I'm sorry about the writing because I'm using the mouse actually. So the day on Venus is 243 Earth days. So in other words, Venus will complete the full cycle around its axis, its own axis, in 243 Earth days, okay, which is a long day. Then also a year on Venus lasts, so Venus will go full cycle around the sun in 225 days, okay? Earth days still, okay? Not Venus days. So you might think that, hey, wait a minute, the day on Venus seems to be longer than the year on Venus, and that's true because of the extreme rotation of Venus around its own axis. However, which day we're talking about on Venus? Is it the sidereal day? This is the sidereal day. This is the day, basically the absolute day, if you want to call it that way. And this is the day with respect to the stars, actually. Let's make it a little bit easy to understand. So here is the deal. So Venus is here. It spins once around its own axis, full cycle, in 243 Earth days. So this is an absolute motion in a sense that if you're sitting on Venus and you're counting the time, once you come back to the next time, look at the star in here in the background, this star in here, and wait for next time when it aligns itself back to the star, that is 243 Earth days. However, we have to be careful in here when it comes to the rotation around the, I made the picture wrong, okay? Venus spinning in retrograde. In other words, it's going back around. So let's look at the sun now. Here is the sun, because this is how we refer to the day on Earth. We look at the sun. And next time when the sun is in the same position in the sky, we call that 24 hours. So let's say, for example, this is noon now on Venus. And it's going to take 225 days to come back for the next time. That is a year, okay? 225 Earth days, that is. But it's spinning backward around its axis. So in other words, this one is not actually moving counterclockwise, it's actually moving clockwise. So this that was here pointing to the sun, it was noon, now it's going to be moving in the opposite direction. So it's going to be moving to, let's say, for example, 10 o'clock in the morning or 7 o'clock in the morning or whatever time you choose to choose, but the day is actually moving backward if you want to refer to the Earth. So if you follow this discussion at some point, that's going to be night and 117 days again. So the planet is spinning clockwise until it reaches this point, okay? So that is the next noon. And the next noon on Venus is not actually 243, it's 117 days, okay? Because of this retrograde motion. Again, I would urge you to go and read section 41.3 from the book. So this is the section from the book, okay? To understand in more depth how that works. Anyway, the point being in here is the solar day. This is the solar day with respect to the sun is 117 Earth days versus the day, the sidereal day, or the day with respect to the stars is 243 Earth days. So that's why now the day actually on Venus is, with respect to the sun, is a little shorter than the year on Venus, okay? So almost half, that is. Okay, So hopefully that is clear enough. So Venus will face the sun in 117 days the next day. So let's say, for example, the Earth and the sun are right now. And I mean, this is what the sun is. Venus and the Earth are, I mean, the Venus is in inferior conjunction. That's what the problem assumes in here. So that means basically it's aligned with the Earth, okay? And this is not necessarily noon because noon is here. So let's say, for example, Venus is giving us this face, okay? And we know from the book that as Venus goes around the sun and Earth goes around the sun, basically 280 or 583.9 days, Earth days later, they will align again in this configuration, meaning that the Venus will become again in inferior conjunction, okay? So 583.9 days again, they will align themselves again, okay? Well, Venus is spinning in this direction, of course, while it's moving around the sun in this direction, 117 Earth days. So these are the comparative numbers that we need to compare them to one another. Okay, I can take 583.9 divided by 117. I will find that this number is very close from 5, not exactly 5. As a matter of fact, it's 4.99. So that means that 5 times Venus spins around its axis. After the 5th time, or at the 5th time, it's going to align itself with the Earth. So whatever was facing Venus at that time with the Earth is going to be the same that is going to be facing the Earth again. So let me explain this a little bit more graphically, and again, up to you later on how you explain that. Okay, so let me illustrate this. Okay, here is Venus. Let's say, for example, this is the face that was facing the Earth. After one day, it's going to face the Earth. It's going to face this way, okay? It's going to face in this direction, that same direction. So this is basically a full rotation. So if the sun was here, and this is noon somewhere in here, so whatever time was in here is going to be that time. That was facing the Earth. Okay, that's 117 days. The second time around, it's going to be 234. That's 2 Venus days. So 2 Venus days is 234 Earth days. Okay. The third time around, this place in here is going to be what? Add the 2 numbers. So you have 1, and you have 4, and then you have 3. After 341 days, the same point that was facing in this direction will face back in here because that's a 3 Venus days. Okay. So this is 3. After 4 times, okay, well, this is just 8, 6, 468 Earth days, more than a year has passed actually on Earth. Then this point in here, 4 Venus days, is pointing in the same direction again. And finally, after 5 Venus days, you will have, well, 5, 8 plus 7 is 15, and 1 plus 6 is 6, 7 plus 1 is 8, and then 585 days, Venus will be pointing in the same direction as it was. And this is exactly when the next alignment is going to be. So this is exactly where Earth is going to be facing this one. I mean, roughly less. I mean, 583 or 584. So it's not going to remain as such because of this discrepancy of a little over a day in here. Okay. So the next time, so this day is this point is shifting a little. So if you wait, for example, hundreds of years or maybe a few decades, this point starts to shift away. But more or less, Venus is going to be facing Earth in the same direction if you wait long enough for it. So that's really an answer to that problem. And hopefully you guys understand it. And I will urge you again to review this section from the book. Now, one more thing from the problem 15, and it's related somehow to this question. Let me explain that is. So here is the sun. Here is the Earth. The Earth, unlike Venus, is rotating in the same direction as it's moving. Both of them are counterclockwise in this example. So when the Earth has spun completely a full cycle around itself, basically went from this position pointing to the sun, which is noon on Earth at this point, okay, to full cycle, basically, it's short of 24 hours in a sense that this point that was facing in here, when it goes to completely, is going to be facing away from the sun. I mean, I'm exaggerating a little bit. So you'll have to wait an extra 4 minutes for it to line up back with Venus. With the, I'm sorry, with Venus, with the sun, okay? So this is 24 hours now has lapsed. But the Earth versus the background stars actually does it in 23.56 days. 23.56 hours, okay? 23 hours and 56 minutes, okay? So in other words, the sidereal day is shorter than the solar day for the case of the Earth by 4 minutes, okay? Assuming that the Earth actually is not spinning in this direction, but rather it's spinning backward, just like Venus does. So it's moving in this direction, but it's spinning backward, okay? Well, in this case, if it was here at that time, and that's noon, before we reach this noon next time, the sun, the Earth will align itself with the sun, and then later catch up itself with the stars. As a matter of fact, in this case, the solar day will be shorter than the sidereal day. Okay, the solar day will be shorter than the sidereal day. Does this ring a bell? Yes, it does. Because this is also the case for Venus, because it's in retrograde motion. The sidereal day, the solar day is 117 days, and the sidereal day is 243 days. So because of the background motion, that's exactly what's going on. And that's what will happen to Earth also, if in case it's going to go in retrograde. Right now, the sidereal day is 23 hours and 56 minutes. Okay. And the solar day is 24 hours on Earth. Okay. If the Earth were to spin backward, the sidereal day will remain this, so it's not going to change. But the solar day will be less than 24 hours, for example, 23 hours. And I don't know, 30 minutes, depending on how fast it's going to move, though. If it's going to move fast enough, the difference will be small, okay? But if it's going to move extremely slower, the difference will be big. Just like the case of the Venus, where the sidereal day is 243, whereas the solar day is less than half that, okay? So in other words, 2 days will still pass on Venus and slightly more before the sidereal day happen, okay? So this is both problems actually, 15 and 14 in more depth. So if you still guys have any questions, please do not hesitate to ask. And this is from the homework that some of you thought that it was due this weekend and sent me emails, but it was clearly stated on Canvas that it is due on the 30th. So I still have time a little bit for it. So if you still have any questions, please do not hesitate. And I can answer those directly, or if it's a general question, I'll be more than happy to discuss it with the entire class. Thank you. So let me stop the recording. I'm gonna stop sharing first. And where is the stop recording?